In section 5.2, it says determine if the following is an identity, and we have to be proving the trig identities. So what they say on the video is that we need to prove that the left side is equal to the right side. So what I'm going to do, I'm going to go ahead and write my problem. So if you want to do this on a separate sheet of paper so you can have more space to work on, I recommend that you do that. That way you don't limit yourself to space. Okay, so problem number one. Number one, it says prove that cosine of x times cosecant of x times tangent of x, it's equals to 1.
Don't you have to write down like 1 over, oh, do you get the reciprocal of it?
So what we need to do is we need to prove that the left side equals to the right side, right?
Yeah.
Okay, so on the t, if I create a t table, I need to prove that the left side is equals to the right side. So you said, what is it that we can rewrite?
You reciprocated? Like,
The reciprocal of what?
oh, cosine, which is cosecant, right? I mean, no, secant, sorry, secant.
Okay,
I know.
that's a good point. Now, something that you need to do in proofs is to look at what is given and to see what's going to be the plan. Okay, because you can substitute a function for many things. But the thing is that you need to kind of like plan to see what's going to be, part of the identity. Like for example, let's look at the second one. What's cosecant?
Cosecant
Mhm.
is 1 over cosine, or cosine, no.
One.
No, cosecant is sine.
So it's 1 over sine.
Yeah.
So the first one is cosine, the second one is 1 over sine. So cosine, sine, can we rewrite tangent in terms of sine and cosine?
Oh,
What
yeah.
is tangent?
Sine over.
Sine over cosine.
Sine over cosine. So you want to change cosine as secant, but why do you want to change it into secant? If you look at the other two pieces, they have sine and they have sine and cosine. So in this case, it's better to just leave cosine the way it is,
What?
okay, as cosine. So cosine, just leave it like that. Let's just put it over 1. And then cosecant, you said that is 1 over sine, which is right. And then tangent is sine, let me change that, theta for x. You have to stick with the same symbol, so let me stick to that. Yes.
So like whenever we have quizzes and tests, we're gonna be able to use that paper that Freddie has?
Yes, make sure you have that paper all the time until the last week of the year.
This is your last,
Yes.
This is your hero.
That's your Bible?
Yes. Well, not too much as a Bible, but yes. Okay, so
You just scratch them out.
let's cross them out. That's right. I like that. Now you can see that we can cross them out. And all of that is just 1, right? So is 1 equals to 1?
Yes.
Yes. So then left side equals to the right side. And here the question is that an identity? Yes, it is. So it is an identity. Therefore, the statement is an identity.
Do we have to write that, therefore, the statement is independent?
Yes.
If we misspell it, is there anything that's off?
Well, after you write that like 100 times, you're not going to misspell it, believe me. So the statement is an identity, period. So number 1, it's B. Okay, problem number 2. In problem number 2, the question is, the problem is sine of theta, sine theta, secant theta. It's supposed to be equal to cosine theta times cosecant theta. Okay. So we create a table.
So do we always wanna, what's it called, have it in, like whatever most of them are, like if most of them are the reciprocal of a, like cosine and sine? Is it you wanna have most of them, then you wanna change sine into cosecant?
Like you said, if most of them are like a certain thing, like sine and cosine or just sine, then try to plan to see if you can visualize it ahead of time.
Okay.
Okay, that way you don't have to go back and erase it and then try it one more time.
So then
Okay.
this one is mostly like secant.
On the left side is sine, and then secant is 1 over cosine. So it would be sine over cosine, and that would be what? Sine divided by
over
cosine?
tangent.
is tangent. So on the left side, it seems like it's going to be tangent. Now, what about on the right side? Cosine. 1 over sine, so it would be cosine divided by sine. So cosine divided by sine is what? Cotangent. So is that going to be an identity? Because it's going to be tangent on the left, cotangent on the right. Are they equal to each other? No. So this one, you're going to have to say this statement is not an identity. The left side is not congruent to the right side. So not equal. Okay, so then let's just rewrite it. Sine theta times 1 over cosine theta. That gives you sine theta divided by cosine theta. And all of this, the question is that equal? Is that equal? I'm putting a question mark on top of the equal. Okay, so that is tangent, right? Tangent of theta. And on the right side, we have cosine theta, and then times 1 over sine theta. When you multiply that, that gives you cosine theta divided by sine theta, and that is cotangent. And that is not equal to each other. So left side is not equal to the right side.
So how? So if it were to be equal, how would it be written? Like would it be tangent equals tangent?
It's left side equals to the right side, right?
So it could be like
Both of them would have to be
The same,
Oh,
right? What's that?
So it could be like sine theta
Equals sine theta. So it has to be the same on the left and on the right. Yes.
the statement. Not
The statement is not an identity.
Can we try number 3 by ourselves?
Go ahead. That's a good idea.
Well, I want to try. Yeah, I want to try.
Yes, please.
Oh,
No, underline. Whoa, whoa, whoa.
I don't know what to do with the plus one.
This is unknown territory.
Okay.
Let's grab our suits first.
Number
Huh?
same way.
I mean, but
Okay.
the plus one probably changes everything. You never know.
No, and then look. They're squares now.
Yeah, there's
Wait,
man.
let's not run before we
It's
can
squared.
walk.
It's like trying to teach a baby
Okay,
how to swim.
I'll take it back. Let's continue then. I started to like your ideas.
Alright.
I was like, hey, that's not a bad idea. Okay, so let's go ahead and do the t-table. And then we have on the left side 1 plus secant squared theta of x. And then times sine square of x. So let's look at the formula chart. So the recommendation is that you put 1 and then plus 1 over cosine square theta, or of x in this case,
Sorry.
and then times sine square of x. Okay, so far so good. Anything else? Let's just put this over 1, okay?
Then you
You can put sine square.
I like that, yes. Sine square of x over cosine square of x. Good job, Chris. Good job, Fern. Now what?
Isn't that,
so you just combine
That's
those.
what. That's 10. That's
yeah,
That's
tangent square.
tangent, that's
so 1
right.
plus tangent squared.
That's all it is. Tangent square of x. And what is all of that together? Look at your identities, the Pythagorean identities.
That's the second one.
That equals.
That's the
right.
second one.
There's a
So
second
it's
one.
secant squared.
Oh, so then it is an identity.
That's right. So
Ooh,
secant
hello.
square of x is just equals to secant square of x.
Ooh.
So is the left side equals to the right side? And it is, right? So, conclusion. So sometimes they look difficult, but once you try it and think about it,
Together, it's easy, but then
Wait till we get home.
Then you start
I'll call you this.
the statement is an identity. Okay, so why don't you try number 4? How's that? Give it a try with number 4. I know you can do it.
just for you.
Oh my God, that's nice.
You gonna show it to her last report
No.
next year's question?
Okay, so Nicole's suggestion, what is it, Nicole? You already saw that coming, right? That it is the left side equals to the right side, right?
Yeah.
Yeah, she already has a plan. Okay, so tell us, share that with us.
Yes, please share.
I said the equation, the cosine squared data
Uh-huh.
equals to the negative sine squared data plus 1.
Negative sine square plus 1. Do you see that on the first Pythagorean identity?
On the right
But
side
it's
of the
X though, 'cause you know, okay.
Oh, X.
Okay, hold on.
Right, x.
Okay.
Do you see that on the first Pythagorean identity? One of the equations there
Wait, miss.
says cosine square theta equals negative sine square theta plus 1. So we're going to use that first one, substitute the negative sine square of x plus 1. We're going to use that to substitute cosine square of x. And then let's just rewrite. Let me just put this as a t, like that.
Is that the minus the sign?
So let me just recopy the sine square of x. Okay.
Wait, hold on.
Now,
Hold on.
yes.
Why did you put negative sine square root right?
Because if you look at the identity, the Pythagorean identity,
Okay.
one of them is cosine square of x equals negative sine square of theta, in this case, plus 1. Do you see that?
Yes, I see it.
So in place of cosine square of x, I'm substituting that for negative sine square of x plus 1. I'm just substituting cosine square.
Okay, now,
For sine.
what tells you to substitute it? Like, what?
You need to visualize this.
To imagine.
Imagine what's going to happen if, well, that comes with a little bit of practice, don't worry, okay? So, it's okay. Therapy session would be like after school if you want to. But right now, let's just continue. Okay, so tell me, the negative sine square of x and the negative sine square of x, together, that makes what?
Oh, they cancel out.
They cannot cancel out.
Oh,
Negative 2.
Negative 2 sine square of x, that's right. You just combine them.
Dang, Nicole had
Plus 1. And now at this point, just by the community property, you can just rewrite that. You can say 1 minus 2 sine square of x is the same thing, right?
Wait, but what happened to the cosine?
Yeah, that's what
We substituted.
We substituted for the
She explained to you when you first asked the question.
You substituted?
In place of x.
because it equals to that.
I still don't. Yes, like.
Was that, it has to be the first one? Okay, you could have used the first one, this one, yeah. And that way you don't have to switch things around, yes. Good, yes.
So we're
So-
on the right path then, right?
You had the idea, that's
No,
right.
it's combined, man.
So left side equals to the right side, therefore, the statement is an identity.
One second, go back.
Sure. This statement is,
I mean, like, if there was another problem like this, I would not know what if I would have to substitute it, you know?
It's because you have to like.
problem number 5 is sine of x multiplied by, okay, that's not in parentheses,
Oh, it is. Oh no, but you're okay.
right? It's just sine of x, and then in parentheses, you have, come on, go. It's okay, go away. Tangent of x, cosine of
I
x.
have a question. How are we gonna use this in the world?
You're going to be the mathematician. They're going to need you to figure it out, stuff, and you're going to have.
They use this in like designing like software and stuff.
No, they look
Nah,
at
it's-
algorithms.
They use zero-one code.
And HTML formats and stuff.
Yeah.
That's what I want to do.
Yeah.
Basically, you say like zero.
You know in beta they have
6.
things like
Well, not that though.
Because I don't think
Such and
HEB
such.
has.
No.
That's.
So now let's go ahead and give suggestions. What do we do here?
Maybe you need
We gotta do
to.
something with that sign.
Sine. Okay, so let
You
me
need to
keep
do something with the parentheses after.
inside the parentheses, right?
Simplify.
Okay.
Yeah, you
What
need
should
to
we do?
simplify.
Okay, simplify is what?
The
Oh,
cosine?
yeah, miss, the cotangent and the tangent, they cancel out, don't they?
No, they don't cancel
They
out.
just equal to 1 though?
It's you subtract tangent cosine of x minus cotangent cosine of x.
Okay, so then
So you
do
cannot
tan-
cancel it.
Oh, okay, you do the
Can you give it?
cotangent is equal to tangent over 1. No. is it one
Now look at what you have there. You have cosine,
Yes.
and then on the outside you have sine.
Yes.
So that's like a clue telling you, okay, you need to rewrite tangent in terms of cosine and sine.
Sine over cosine.
There you go. So tangent could be sine over cosine. Let me just keep cosine of x the way it is, and just put it over 1. And then cotangent, let's rewrite it in terms of sine and cosine, so that would be cosine over sine. And let me keep the cosine of x over 1. Okay? So now, I just use sine and cosine.
Sorry, just ask first.
So now, any other suggestion? What are we supposed to
Cancel out
do?
whatever we can.
Cancel out whatever we can. So in this case, we can cancel out
Cosine, cosine, and then cosine, cosine. Or
Okay.
cos,
cosine, cosine.
Sine,
Okay.
sine.
and then sine over there.
Be careful. Where's
Oh, the negative.
there's no sign that I can cancel out in the second part. See here?
Oh, they're separated.
There's nothing, right? It's separated. See?
Oh.
So no. So
Did you
now,
cancel out the
Wait,
cosine?
which one can't you?
So then right now, on the left side?
The sine.
so here, cosine of x times cosine of x, that's going to be cosine square of x,
Why
right?
can't you cross them out again?
Because they're split into two.
Right. If you were to have
Oh, they have to be
times
across
this,
each other, like-
it's got to be multiplied, so you can cancel it out. Yes. Okay, so then in this case, we can just rewrite cosine x times cosine of x is cosine square of x. And we just leave this by itself. Okay, so let's just rewrite it.
I thought it was 2 cosine.
Oh, no, we don't use sine. Oh, yeah, we do.
Here,
Sine of
right, so
one.
what's left over is sine of x, right?
We were adding it.
Yeah.
Minus
One.
cosine square of x over sine of x. You just want to put it as 1 over 1, that's okay? Okay. So now, there's nothing else we can simplify inside the parentheses. The only thing we can do is just distribute with the outside, right? So let's go ahead and distribute with the sign. So we're going to distribute like that. So that would be sine square of x minus, let me just rewrite sine of x times cosine square of x over sine of x. Okay, so I distributed the sine of x. Is there anything that you suggest to do?
You cross sine of x?
There you go. You can cross out sine of x because now it's being multiplied by the other fraction. So here we can cancel that out. Yes. So when you rewrite that, that's going to be sine square of x.
Why did you keep the, like, after you distributed,
Uh-huh.
why did you keep the sign x over 1?
This one,
Yeah.
because it's still here.
Yeah, because there's a fraction on this side, so we can make it a
Right.
fraction.
The only ones that cancel out with the cosine.
No, like, again, when you distributed.
When
He's
you,
talking about on the 3rd row, the one above sine squared x.
this one?
Sign
No,
square
no,
x.
lower.
Where you
Down.
distributed sine x to cosine x squared, cosine squared x. We distributed to that one. Why did you keep it sine of, yeah.
This one? Because when you multiply this times that, see, you cannot really multiply like that. There's nothing that you can do with these two, so just put them right next to each other. So you just recopy it, and then just recopy it. But make sure you keep
The minus goes
the
away.
negative.
Oh, no, it doesn't.
The minus still here.
Okay, it just goes
Right.
in front of it.
Right. Okay, so now, the bell's gonna ring, is 1 minus 2. Remember that if you want to have cosine, the homework would be just to complete this worksheet, the front and the back. Don't worry about the algebraic identities on top. Just try the bottom. Okay?
I'm saying they finish the problem?
Yes. You want me? Okay, so this is the same thing as 1 minus cosine square of x minus cosine square of x, right? Because that's what sine square of x is. This. And then it's the same thing as 1 minus 2. Have a great weekend, guys.
Oh, it's Friday.
It is, yes. So there's a proof. Left side equals to the right side.
Wait, so you don't do anything to the right? Oh, yeah, this, wait. You did, miss.
Likewise, thank you. Yes, I did. I substituted sine square of x for 1 minus cosine square of x. Just like the other problem,
Yeah.
it's the same thing here. On the top tray, please. Good job.